This is the swing set at the Tarr family playground. The playground was originally built in 1935 and 1936. You will notice the swings all hang from chains of the same length. Why would longer chains connected to the swing as opposed to shorter chains make the period longer? The swings mimic the motion of a pendulum. The longer the length of a pendulum, the greater the period will be. We can see that if the length of the swing chains increases, the swing seat will have to travel farther to reach the same height. If all other factors aside from the length of the period remain constant, the period will have to increase as the swing seat will take longer to cover the larger distance. These images demonstrate what a swing with longer or shorter chains might look like. We can see that a swing seat with longer chains as opposed to shorter ones will have to travel a farther distance in order for the swing to travel the same angular distance. Because of this, if the swings move at the same pace, it will take the swing with longer chains more time to cover the longer distance. This means a swing with longer chains will have a longer period. This is the rope jungle gym at the Tarr family playground. The playground was renovated in 2009 and added this feature. If you attempt to move the rope, you will notice that the rope is harder to move when more people are hanging from it, as opposed to when fewer or no people are hanging from it. Why is the rope harder to move when 2 people are hanging on it than when 1 person is hanging from the same rope? This video demonstrates a rope when someone is hanging from it. Ignore the sensors shown in the video. The tension in the rope is what makes the rope easier or harder to move. The tension force acting on the rope is dependent on the mass of the object hanging from it. In the case of 2 people, the mass is greater than that of only one of them. Because of the greater mass, the tension in the rope will increase. When there is a greater tension in the rope, it will be harder to move. This is the Firepole at the Tarr family playground. This feature has been at the playground since before the 2009 renovation. You will notice that people sliding down the Firepole do not all reach the ground in the same amount of time. Why does wearing wool gloves, as opposed to bare hands, increase the speed at which someone slides down the Firepole? When an object, in this case the person's hands, slides against another object, in this case the Firepole, friction is created. This frictional force will work in the opposite direction of the sliding person, decreasing their speed. If the surfaces sliding against each other are rough, the frictional force will be greater, and if they are smooth, the frictional force will be smaller. The surface of wool gloves is smoother than a person's hands, so it will decrease the frictional force created by the person sliding down the pole. If there is a smaller frictional force acting against the person, then their speed will decrease by less, allowing them to slide down the Firepole at a greater speed. These are the sprinklers at the Tarr family playground. During the warmer months of the year, they are turned on for people to enjoy cooling off in the hot weather. You will notice that a rainbow appears when the sprinklers are turned on during a sunny day. Why does a rainbow appear when the sprinklers are running during the day but not at night? Rainbows are caused by the refraction of light. Refraction is the bending of light as it passes from one transparent substance to another. In this case, the light is passing from the air to the water. Light is made up of different colors with different wavelengths that refract from the water at different angles, which separates the colors, making a rainbow appear. In this case, the source of the wavelengths that pass through the different mediums, air and water, is the sun. A rainbow will not appear at night because the light source, the sun, is no longer present.